Working with the intermediate value theorem, unit 1.16. If f of x is continuous on interval a through b, f of a cannot equal f of b. Then for every y value between f of a and f of b, there is a c in a in h such that n equals fc. So, number one, use the table for question number one. There are values on the table, and I decided to plot them down on a graph, just the points. The lines will come in later. Question A, on the interval of x is less than or equal to x, which is equal to or less than 10, what is the minimum number of zeros? So zeros are when the line crosses over the zero line, the x-axis, and I drew the dots, and these lines aren't the exact path that they went, but it's a rough estimate to show you the minimum amount of times it can cross zero. So it's 0 is at a positive 2 and goes to 2 of negative 2. So it has to cross a 0 at least once, somehow or some way. Goes back up above 0, so that's one more. Keeps going up. It could go down and up again in between that 4 and 8, but we don't know. This is just a minimum amount of times. Goes up, and it goes down again, so that's a minimum of 3 zeros. Question B. On the interval 2 is less than or equal to x, which is less than or equal to 8, what is the fewest possible times f of x equals 1? So if f of 2, which is within this interval, equals negative 2, right? Which is less than 1, and f of 8, which is equal to 6, is greater than 1, then it's 1. That's the fewest possible times that f of x could equal 1, but it could also equal more. C. On the interval 0 is less than or equal to x, which is less than or equal to 2, must there be a value of x for which f of x equals 1? Explain. I said yes, since f of 0, which is 2, is greater than 1, and f of 2, which is equals to negative 2, is less than 1, then by the intermediate value theorem, there is